Hi guys, welcome back. In the last session, we completed our discussion related to pods, services types, and the namespaces. And we discussed that it is not recommended to create the pod manually because when we delete the pod, Kubernetes is not recreating the pod. In order to create the pods in the Kubernetes provided several components. One is replication controller. Second one is replica set. Third one is a deployment. Fourth one is a stateful set. And the fifth one is a daemon set. So like this, there are several Kubernetes components. By using these Kubernetes components, we will create the pod. Right. What is the advantage if we go for these components? If we go for these components, Kubernetes will manage our pod lifecycle. If any pod got deleted, then Kubernetes will recreate that pod. Kubernetes will maintain given number of pods are always running for our application. So first one, we are trying to understand what is replication controller. In Kubernetes, it is one component, right? So there are several components available. So in those components, replication controller is the one of the component. So by using this component, we can run given number of pods for our application. Whenever we use a replication controller, it will take care of pod lifecycle. When pod is crashed or damaged or deleted, then replication controller will create the new pod, and we can scale up and scale down pods count using replication controller. Okay. Now let us try to write the manifest YML to create the pods by using this replication controller. So earlier we created the manifest YML only to create the pod manually and expose the pod by using service. Now I will write the manifest for replication controller. I will write the manifest file for the replication controller, and I will create the pods by using replication controller, and I will expose the pods by using service. Now let us see what is the manifest file for that. So in the manifest file, I'm writing two things here. One is replication controller specification, and another one is service specification. Let me end that. Okay. So here, if we see API version will be available first. Replication controller will coming under version V1. Kind will be available. Spec metadata will be available. And the spec also will be available. So this is for replication controller manifest, and this is for service manifest. API version, kind, metadata, and spec. Coming to the kind, here I want to create replication controller. API version is V1 and the kind is replication controller, and metadata in the this is metadata for replication controller. I'm going to give it as Java Web Application RC. API version is V1, kind is replication controller, metadata. In the metadata, I'm giving the name for that as a Java Web Application replication controller. And coming to spec, in the spec I'm giving replicas. In the spec I'm giving replicas as a 3. When I give replicas as a 3, that means it will create 3 pods for our application. In these 3, if any one pod is deleted, we no need to worry about that. Replication controller will take care of that. So last time, when we create a normal manifest YML, so here there is no replica, right? It is a normal pod manifest we have written. But now I'm writing replication controller manifest. In the replication controller manifest, we are going to specify the specification. Under that, we are going to specify the replicas. Replicas I'm giving as 3. And for this, we need to specify selector, right? In the selector, I'm going to specify app as Java web app. So this selector is used to identify the pod by using this label. Now, API version is V1, kind is replication controller, metadata, name is Java Web Application replication controller. Under the specification, we are writing 3 replicas. Under the selector, we are writing the label as Java web app. Then Next one is we need to go for template. This is a pod template that we are writing. So last time the pod template was not available. Directly under metadata, we use it to write the labels for the pod, name for the pod. But now we are writing replication controller. In the replication controller specification, we need to write the pod template. In the pod template, we need to write metadata. Under the metadata, we can give the name for the pod, Java Web Application Pod, and label for the pod. So label, what are the label? Already I'm using this as a selector. So the label also should be available here. App : Java Web App is the label. Okay. App : Java Web App is the label. Now then here, I need to write the pod specification. In the pod specification, we need to specify containers information. For the container, I'm giving the name as Java Web App Container. And the image, I need to run the image ashokit / Java Web Application. And ports mapping we need to specify. So here in the ports, container port we need to specify. Container port is 88. So this is our replication controller manifest YML. Guys, check this. So the indent spaces are very important here. API version is a V1. Kind is a replication controller. Metadata web application replication controller. Under the specification, replicas count I'm giving as 3. And the selector I'm giving as a label name. Template is there. And the metadata, name, labels, and specification inside that containers available. Inside the container, the name is Java Web Application Container. Image is ashokit Java Web App. And ports, container port we are giving as 88. So here, this is representing pod template. This is representing pod template. Okay, guys. And this is representing RC specification. RC means replication controller. With this template, our pod will be created. Our pod is having a label called Java Web App. So this pod we are identifying by using selector, and for that we are giving 3. That means based on the pod template, 3 replicas will be created by replication controller. So this is a pod template. Based on this pod template, 3 pods will be created by replication controller. Now, how to expose the pods? In order to expose the pods, we will write a service manifest. Right, API version, kind will be available, metadata will be available, and the spec will be available. Okay, kind will be available, metadata and spec. API version, that is V1. Kind is a service. Kind is a service I want to create. Metadata, name is Java Web Application Service. And coming to specification, type I am giving as node port. Type I am giving as a node port. Selector, pod label. Our pod is Java Web App. Our pod is Java Web App. And then we need to specify ports for this. We need to specify the ports. So here, normal port, internal port is 80. And target port is 8080. And node port is 30785. Right? Node port I'm giving as 30785. You can give any port number for the node port. If you don't give the port number, then Kubernetes will generate a random port for that. Got it? So here, 2 things available. One is replication controller specification. Another one is service specification. So here, this is my pod specification, pod template. So this pod template will be used to create 3 replicas. 3 replicas means 3 pods will be created. For our application, 3 pods will be created by replication controller. From these 3 pods, if you delete one pod also, no problem. Replication controller is going to recreate that pod. Now, once the pods are created, I want to access the pods outside the cluster. For that, we are writing a service. Node port service I'm writing to expose the pods outside the cluster. Now, save this YML, take this YML, go to here. My nodes are up and running. kubectl delete all, _all. I want to delete everything available in the Kubernetes. Now, pod is deleted, service is also deleted. Let us check kubectl get pods. Pods are not available. kubectl get nodes. Nodes are not nodes available. kubectl get service. Now, service is not available. Let me create the pods by using replication controller. virc.yml. RC means replication controller. Now, keep this manifest. Keep this manifest. This is replication controller manifest and this is service manifest. Okay. Now let us save this file and let's apply. kubectl apply -f rc.yml. kubectl apply rc.yml. Now if you observe, you can see replication controller is created and service is created. Now let us check kubectl get pods. When we check the kubectl get pods, what is happening now? How many pods are getting created, guys? Is it creating one pod or it is creating 3 pods? For our application, 1 pod is created or 3 pods are created? Tell me. For our pods, for our application, 1 pod is created or 3 pods are created? For our application, 1 pod is created, 3 pods are created. 3 pods are created. Why 3 pods are created for our application? Why we can create 3 pods? Why we 3 pods created for our application? What is the reason for that? We have given the replica count as 3. We have given the replica count as 3. You see, Java Web App RC, one random name is given for each pod. Each pod is having one random name. One random name is assigned for the each pod. Java Web Application RC, and this is the name of the pod. This is the name of the pod. This is the name of the pod. Now, 3 pods are running. Now let me delete 1 pod from here. Observe clearly. We are having 3 pods. kubectl get pods. 3 pods are running. Let me delete 1 pod. kubectl delete pod. I'm deleting 1 pod. So 109 seconds ago, the pods are created. Now I am deleting 1 pod by using kubectl delete pod and pod name. Right? Click on delete. Yes, now the pod got deleted. After pod got deleted, get the pods. Now, can you see 4 seconds ago, a new pod got created? Can you see earlier 109 seconds ago, 3 pods available. From that, I have deleted 1 pod. When I delete 1 pod, a new pod is recreated or new pod is not recreated? Come on, guys. So am I creating the pod or Kubernetes is recreating the pods when 1 pod is deleted? Kubernetes is recreating the pod when the pod is deleted. So can I say it is self-healing capability in the Kubernetes? Can I say this is a self-healing capability in the Kubernetes? If I create the pods manually, am I getting this feature or we are not getting this feature? If I create the pods manually without using replication controller, am I getting this or I am not getting this? No, we are not getting this. We are not getting this. Got it? Now, here, let us check the service which is available. kubectl get service. kubectl get service is available. So what is our service type now? Our service type is node port service and the port number 30785. Now 3 pods are running. But can we check in which nodes those pods are running? How many worker nodes we are having? In our cluster, how many worker nodes we have and how many pods are running? Come on, guys. How many worker nodes we have and how many pods are running? 2 worker nodes we have, 3 pods are running. Now, Let us check that in which node, which pod is running. Get pods -o wide. Okay. Can you check it? Can you check it? Which pod is running in the which worker node? In the first worker node, 2 pods are running. In the second worker node, 1 pod is running. In the first worker node, 2 pods are running. In the second worker node, 1 pod is running. Are you guys clear? Are you guys clear? I'm creating pods. So yesterday we created the pods manually by writing a pod manifest like this, by writing the kind as a pod. But today I'm not writing the kind as a pod. I'm writing the kind as a replication controller. Replication controller is a Kubernetes resource which is used to create the pods. The advantage with the replication controller is whenever we want to create the pods by using replication controller, we will give the replicas count. I have given the replicas count as 3. When I give the replica count as 3, always it will maintain 3 replicas of our pod. From these 3 replicas, if you delete one pod also, Kubernetes will recreate that pod. So Kubernetes will maintain the given number of pods always in the cluster. 3 pods I have specified. Always 3 pods will be available. If any pod is deleted, it will automatically recreating the new pod. How many times it will recreate the pod? Still your replication controller is running in the Kubernetes. N number of times it is going to recreate the pod. So it has to maintain 3 pods as per my configuration. If any pod is deleted from the 3, then it is going to recreate that pod. Clear? Now, so there are 2 worker nodes available, but replicas I have given 3. Then what happened? In first worker node, 2 pods are created. In the second worker node, 1 pod got created. Now here, you can check the replication controllers available here. kubectl get RC. RC nothing but replication controller. So this is my replication controller name. Desired pods 3, current pods are 3, ready pods are 3. 6 minutes ago, this replication controller is deleted. Now here, if you want to delete your application, you should not delete the pod directly. You need to delete your replication controller concept. If you delete your replication controller, then the pods will be deleted. If you delete the pod manually, what will happen? That pod will be recreated. If you delete the pod, that pod will be recreated. If you want to delete the pods, you should not delete the pod directly. You need to delete the replication controller. How to get the replication controller? kubectl get RC. kubectl get RC means the replication controllers we have created, it is displaying here. The replication controllers we have created, it is displaying here. Now here, we can scale up our application and we can scale down our application. How to do the scale up of our application? Now let us see kubectl scale RC. What is the RC name? Replication controller name. Java web application, replication controller, replicas, replicas. I'm giving as 5. So currently how many pods are running? 3 pods are running. I want to scale up my application. I want to give the replica count as 5. Then enter. Now replica controller got scaled. Go for the pods, -o wide. How many pods are running now? Earlier there are only 3 pods available. Now 2 pods are created. 1 pod is created in the first worker node. Another pod is created in the second worker node. Now if you see in the first worker node, 198 node, 3 pods are running. In 197 node, 2 pods are running. So I asked Kubernetes to create the 3 pods. From the 3 pods, I have deleted 1 pod. When I delete 1 pod, Kubernetes recreated that pod. Then after, I want to scale my replication controller. I want to increase the pod count. When I want to increase the pod count, I'm using kubectl scale RC Java web app replication controller replicas 5. 5 replicas I want. That means I'm increasing the pod count. So here it has created 5 pods. It increases the count to 5 pods. Are you clear? Are you guys clear here? Now, in the first worker node, how many pods are running? In the first worker node, 3 pods are running. Now here, let us go to our machine, take the public IP, hit the URL. Now, 8080/Java web app. Now, check it. Am I able to access my application or not? Sorry, 30785, not 8080. The port number is, the node port number is 30785. With this 30785, I'm able to access my application, which is in the first worker node. In the first worker node, how many pods are there? In the first worker node, total there are 3 pods available. When I hit the URL in the browser, request is going to which pod? We don't know. That will be taken care by Kubernetes internally. We are sending a request to the node by using node IP. In that worker node, 3 pods are running. Which pod processed our request? We don't know. Kubernetes will handle that internally. Now, if one pod is deleted, our application will be down, or our application will not be down if one pod is deleted. If one pod is deleted, our application will be down, or our application will not be down now. Guys, come on. In the first worker node, 3 pods are running. 3 pods are running. I'm sending a request to that node. So which node, in that node, 3 pods are there. Which pod processing our request? That will be taken care by Kubernetes. Come on, guys. If one pod is deleted, then application will be down or application will not be down. If one pod is deleted, our application will not be down because pod will be recreated. Pod will be recreated. So out of 5 pods, I'm sending the request to the first worker node. Then what about the second worker node pods? They will not receive the request. If you want to access the pods in the second worker node, then you need to go for second worker node IP address. If I want to distribute the load to all the 5 pods, then which service type I need to use? I should go for node port or I should go for load balancer. If I want to distribute the traffic to 5 worker nodes, I should go for load balancer or I should go for node port? Load balancer. If you go for node port, what is the problem? Always the requests are going to one single machine. Always the requests are going to single worker node. In that single worker node, there are 3 pods available. But total for my application, 5 pods available. If I want to distribute the traffic to 5 pods, then I need to create that service type as a load balancer. Are you clear? What is replication controller? Replication controller is a Kubernetes component which is used to create pods. It will make sure always given number of pods are running for our application. It will take care of pod lifecycle. When pod is crashed or damaged, deleted, then replication controller will create the new pod. We can scale up and scale down the pods count using replication controller. Okay. Now here, this is my manifest YML for creating replication controller. So what is the command that we are going to use? First, we are going to use kubectl delete all all. Delete everything. Then kubectl apply -f rc.yml. RC is my manifest YML. Then we can check kubectl get pods, and we can check kubectl get service, and we can check kubectl get RC. Get RC nothing but what is the replication controller that we have created, we can check that. Right. If you want to scale up the pods, you can go here and you can execute this command to scale up your application. Replicas 5. Suppose if I execute the same command with a count as 3, then it will be scaled down to 3 pods. Now check the pods count. So earlier there are 5 pods available. Now I have given, earlier there are only 3 pods available. From 3 pods, I scaled to 5 pods. Then 2 pods are newly created. Then again I'm scaling down. I'm decreasing my pods. Here, scale up, scale down, I'm doing manually. But in the Kubernetes, auto scaling is also available. We will discuss auto scaling in the coming classes. So here, kubectl scale RC Java web application 5 replicas. So for the pods, for the application, 5 pods will be created. And I have given again replicas as 3. When I give the replicas as 3, from 5 pods, it reduced to 3 pods. So in the 3 pods, 2 pods are in the first worker node, 1 pod is in the second worker node. 1 pod is in the second worker node, 2 pods are in the first worker. So like this, you can increase the pod replicas and you can decrease the pod replicas by using this replica option. So it is used to delete everything available in the cluster, and it is used to create the pods by using manifest YML. To check what all the pods available, pods -o void. It will give you in which worker node which pod is running. You can check what is the service. When you run the svc command, it will tell you what is the node port it is using. Get RC, what is the replication controller we have created. Increase the pod count and decrease the pod count. Now, if I want to delete my application from the cluster, if I delete the pod, application will be deleted, application will not be deleted. Guys, if I delete the pods, application will be deleted or application will not be deleted. Come on. If I delete the pod, application will be deleted or will not be deleted. Now see here, I'm going here, I'm executing a command, kubectl delete pod. Now, from the first worker node, I want to delete 1 pod. kubectl delete pod, pod name. After deleting the pod, get the pods which are available. 1 more pod is created. Here, 5 seconds ago, 1 more pod is created. The remaining 2 pods, earlier, there are 3 pods available. They are created 17 minutes ago, 14 minutes ago. I have deleted 1 pod. When I delete 1 pod, that pod got recreated 5 seconds ago. So if I delete the pods, application will be deleted or application will not be deleted. Will not be deleted. Why? Replication controller replicas are 3. Replication controller replicas are 3. Always it will create the new pod if the count is below 3. If the count is below 3, always will recreate the pod. Guys, clear? Now I want to delete my application from the cluster. How to delete application from the cluster? If I want to delete the application from the cluster, how to do that? Yes. Now here, guys, my application running in 3 pods. So that means I can say 3 containers are created for my application. One container is running in the second worker node. I mean, one pod is running in the second worker node. 2 pods are running in the first worker node. Now, if you want to delete the application, you should not delete the pods. If you want to delete the application, then we need to delete our replication controller. How to do that? kubectl delete rc name. kubectl delete rc name. When we delete the rc, then if you check the pods, then the pods will not be available. So whenever you create the pod by using Kubernetes resource, always it will maintain given number of pods. If I give 3 replicas, always it will maintain the 3 replicas. If any one pod is deleted, it is going to recreate that pod. It is going to recreate that pod. So if you want to delete the application, then we need to delete our RC. kubectl delete RC, and our RC name is Java Web App RC. So in this manifest file, I have given the name for RC. So metadata name I have given. If you want to delete your application, you need to delete your RC. Then all the pods will be deleted and your application also will be deleted. Got it? Then what about service? kubectl get a service. Now service is not deleted, service is available, but our replication controller deleted. The pods which are created by the replication controller also got deleted. Are you clear? Are you clear? Someone is asking, if you scale the pods by using the command, will it reflect in the manifest YML? No, it will not reflect in the manifest YML, but pods will be increased in the cluster. Manifest YML will not be changed. By using manifest file, we are creating the replication controller, right? So here, whenever we scale the pods, YML file will not be changed, but in the cluster, our replication controller configuration will be changed. YML file will not be changed. In the YML, the still replicas will be 3 only. Within the cluster, the pod count will be increased and pod count will be decreased with these commands. If you want to delete the pods, if you delete the pod directly, pod will be recreated. Pod should not be deleted directly. We need to delete the replication controller. Are you clear? What is replication controller and what is the benefit we are getting with the replication controller? What is the benefit we are getting with the replication controller? Guys, what is the benefit with the replication controller? Self-healing capability. Self-healing capability. This replication controller will manage our pod lifecycle. If any pod is deleted, then it is recreating that pod. In Kubernetes, we are deploying our application as pods, right? Pod is the smallest building block that can run in the cluster. Pod is a smallest building block that can run in the cluster. So if we create the pods manually, if the pod is deleted, then application will be down. So here we should not create the pod manually. Pod should be created by using Kubernetes component. What are the components available? Replication controller, replica set, deployment, stateful set, and daemon set. In the replication controller, we are giving the replica count as 3. So always it will maintain 3 pods for our application. Those 3 pods will be maintained in the which worker node? We can't predict that. That will be taken care by Kubernetes. We will tell Kubernetes to create 3 pods. It may create all the 3 pods in one worker node, or it will distribute 2 pods to one worker node and 1 pod to other worker node. Got it? So where in which node the pods will be created, we can't tell to Kubernetes. Kubernetes will decide in which worker node it has to create the pods. After the pods are created, in which node they have created, you can check by using this command, get pods-o wide. So if you want to increase the pod count, after your pods are created, you want to increase the pod count, then you can go for scale command. If you want to decrease, so this, if you give the count as 5, then currently 3, and I have given 5, 2 more pods will be created. And delete the RC. It is going to delete the replication controller, which is available in the Kubernetes cluster. Got it? Fine. Next one. Replica set is available, guys. There is another component in the Kubernetes cluster, that is replica set. So what is this replica set? This is also kind of replication controller only, but it is the advanced version of the replication controller. Replica set is the replacement for replication controller. It is the next generation component in the Kubernetes. Replica set is replacement for replication controller. Already we have replication controller. Here, as a replacement for the replication controller, replica set came into picture. Replica set is replacement for replication controller. It is a next gen component. It is next gen component, next generation component in the Kubernetes. Okay, so replica set is also used to manage pod lifecycle. Replication controller managing the pod lifecycle. Similarly, replica set is also used to manage pod lifecycle. Replica set also maintains given number of pods all the time. Replica set also will maintain given number of pods always. If I give the count as 3 replicas, always it will maintain 3 replicas. Whatever is there in the replication controller, same thing is available in the replica set also. Replica set is the replacement for the replication controller. It is next gen component in the Kubernetes. Replica set is also used to manage pod lifecycle. Replica set also will maintain given number of pods always. Now here we can scale up and we can scale down our pods by using replica set also. We can scale up and we can scale down. We can scale up and we can scale down our pods using replica set also. We can scale up and we can scale down our pods using replica set also. Then I see here, what is the difference between replication controller and replica set? Now here, the difference between replication controller and replica set is the only selector to identify the pods. Selector is used to identify the pods. Okay, so in the selector, we are going to configure pod label. So here I have given a pod template. In the pod template, pod label is available. Based on this label, this replication controller will identify the pod. So in the replication controller, we are writing the selector. In the replica set also, we will write the selector. But the selector functionality is different from replication controller to replica set. The only difference between replication controller and replica set is in selector is selector. Okay. So what is a selector in the Kubernetes? Selector is used to identify the pod by using pod label. Now replication controller should create the pod. Which image it has to use to create the pod? Right. So here pod is having a template. In the pod template, we have given the image name and the port. So by using this template, it has to create the 3 pods, 3 replicas, right? So selector, label of the pod. So in the Kubernetes, labels and selectors are very important. For the pod, we will give the label. So to identify that pod, we are going to use that label as a selector. The only difference between replication controller and replica setter is selector. Is a selector. You got it? Now here, replication controller supports equality based selector. Replica set supports set based selector. Replication controller supports equality based selector. It supports equality based selector. Replica set supports set based selector. That is the difference. Sir, what is the meaning of equality based selector, set based selector? The example here, we are going to specify the selector as a single label. Selector app : Java web app. So if the pod label is matched with this selector, then that pod will be identified. That is called equality based selector. Replication controller supports equality based selector. So when I'm writing the replication controller, selector I'm giving as a label. If a pod label matches with this well label, if the pod label matches with this selector, then only that pod will be identified. Are you guys clear? Are you guys clear with my point? What is the difference between replication controller and replica set? Replication controller supports equality based selector. Replica set supports set based selector. So what is the meaning of equality based selector? Selector app Java web app. Selector app Java web app. So here, if the pod label matches this with value, if the pod label matches with this value, then only that pod will be identified. Whereas in the replica set, the labels can be set based. That means multiple labels we can configure when we go for replica set. Selector, here we are going to specify match labels. Under the match labels, we can give multiple labels. Java web app, okay. Version is V1 for the pods, something like this. And the type of the pods I'm giving as backend pods, like this. So when you go for replication controller, we can configure only one label. But in the replica set, our pods can be identified by using multiple labels. This is set of labels you can configure for the selector in the replica set. When you go for replication controller, only one label we are going to configure. Equality based selector will be there in the replication controller. Set of labels can be configured in the replica set. This is the only difference between replication controller and replication set. How to identify the pods? The pods can be identified by using pod label. So in the selector, we need to configure the pod label. Replication controller supports equality based selector. Replica set supports set based selector. Okay. Now, in order to deploy our application by using replication set, what change we need to do? The only change is kind will be changed and version will be changed. And these labels selectors also is going to be different. Now let me take this YML. Let me create it rs.yml. What is the meaning of rs.yml? Replication set YML, rs.yml. Service manifest is not going to change. Service manifest is not going to change. Here, version will be apps/v1. Replication controller version is v1. Replication set version is apps/v1. And here, instead of replication controller, we need to give it as a replica set. We need to give as a replica set. Under the selector, label we cannot configure directly. Under the selector, we need to configure match labels, set-based labels. Inside that, I'm configuring one label. You can configure multiple labels also. That is the only difference. API version I'm giving as app/v1, kinda replica set, and replicas 3. Inside the selector, I'm giving the match labels. In the match label, I'm giving the pod label. So based on this pod label, it will identify the pods. Here my pod specification is available. In the pod specification, that is called pod template. In the pod template, I'm giving the label name as app:/Java web app. So by using this, it will identify our pods and it will create the pods with the 3 replicas using replica set. Right, save it. Now take this file, go here and delete everything which we have created now. kubectl delete all -all. kubectl delete all -all. Before that, you can execute kubectl get all -all. kubectl get all. When I execute kubectl get all, only my service is running, pods are not running. Let's delete that. kubectl delete all -all. I want to delete everything here, -. I want to delete everything. My service is deleted. Now let us create one file, rs.yml. This is my replication set YML. Sorry. vi rs.yml. In this, I need to keep my manifest YML. Manifest YML. Kind is replica set. Name is Java Web App RS. I will change the name to replica set. Replicas 3. Match labels I'm giving as Java Web App. If it is replication controller, directly we'll give the label under the selector. But here we added match labels. That means multiple labels we can configure for the selector. Good. Now let's execute. Before that, kubectl get pods. Nothing is available. kubectl get service. Nothing is available. kubectl get rs. Replication set. kubectl get rs. Nothing is available. Pods are not there. Service is not there. Replica set is also not there. Now let us create that by using manifest YML. kubectl apply -f rs.yml. Now you see, when I apply that, it created my replica set and it created a service also. Now go for pods, kubectl get pods -o void. 3 pods will be created. 14 seconds ago, 3 pods are created. 2 pods created in the first worker node. 1 pod is created in the second worker node. Out of these 2 pods, if I delete 1 pod, it will recreate that. Self-healing. Self-healing will be available in the replica set also. kubectl delete pod with the pod name. I'm going to delete the last pod. kubectl delete the pod. I deleted the pod. Now execute. Yes. 3 seconds ago, 1 more pod got created. So pods are recreated in the replica set. Pods are not recreating in the replica set. Pods are recreated. Pods are not recreated. Pods are recreated. Pods are not recreated. Come on. Yes. How to check the replica set here? kubectl get rs. Yes, replica set is created. If I want to delete the pods, can I do manual deletion for the pod? If I do manual delete for the pod, what will happen? It will be recreated. If I want to delete all the pods, we need to delete the replica set. We need to delete the replica set. Okay, good. So this is RS, my replica set YML. Manifest YML for replica set. How to create this? Same commands. The only difference is instead of RC, we will use RS. That's it. Here also same process. You can delete everything. You can create the manifest by using rs.yml. You can get the pods, get the service. If you want to scale instead of RC, you need to use RS. That's it. Earlier we used RC to scale the pods. And now, earlier it was replication controller. So we used RC. Now it is replica set. For that, we will go for RS. You can scale up, you can scale down, you can delete. You can scale up, you can scale down, and you can delete the pods. Clear? What is replica set and what is replication controller? These are Kubernetes components. Always we need to create the pods by using Kubernetes components. Replication controller, replica set, deployment, stateful set, and daemon set. Come on, guys. Good. Both are same. The difference is multiple labels we can configure. Match labels. Based on the multiple labels, we can identify the pods. That is the only advantage here. Earlier, we need to go for equality based selector. Now we can go for set based selector. Equality based selector, and now we can go for set based selector. Okay, good. The next one and the most important one, that is deployment. The next one and the most important one in the Kubernetes is deployment. Deployment is the most recommended approach to deploy our applications in the Kubernetes cluster. So deployment is another Kubernetes resource. As we have replication controller and replica set, similarly, deployment is another Kubernetes resource. Deployment is one of the Kubernetes resource, or I can say component. Deployment is the most recommended approach to deploy our applications in Kubernetes cluster. We can deploy the application by using replication controller. We can deploy the application by using replica set, and we can deploy the application by using deployment concept also. Deployment is one of the Kubernetes resource, or I can say Kubernetes component. Deployment is the most recommended approach to deploy our applications in the Kubernetes cluster. And in the replication controller and replica set, that scaling is a manual process, whereas in the deployment, we can achieve auto scaling. We can achieve auto scaling when we go for the deployment concept. Deployment is one of the Kubernetes resource or Kubernetes component. Deployment is the most recommended approach to deploy our applications in Kubernetes cluster. Using deployment, we can scale up and we can scale down the pods manually as well as auto scaling also. Using deployment, we can scale up and we can scale down our pods. Okay, guys. Deployment supports rollout and rollback. Deployment supports rollout and rollback. Okay, I have done my code deployment in the cluster, but my latest code is not working as expected. Then I can roll back the deployment so that we can go to previous version of our deployment. Rollout means I want to roll out the latest code to the cluster. I can do that. After doing the latest code deployment, we found some issue in the code. Now we want to go back to previous version. Then we can go for rollback. Rollout and rollback concepts are available in this deployment concept. Okay, guys. We can achieve zero downtime. We can achieve zero downtime of our application by using deployment. Suppose I have deployed my pods by using replication controller or replica set. Now I want to deploy the latest code. To deploy the latest code, to deploy latest code, we have to delete RC and RS. To deploy latest code, we have to delete replication controller and replication set. Then pods will be deleted. And application will be down. To deploy the latest code, we have to delete RC and RS. Then pods will be deleted and application will be down. We can deploy the latest code. We can deploy latest code with a zero downtime. Using deployment. Okay. So when you create the project deployment by using replication controller or replica set, I want to deploy the latest code. When I want to deploy the latest code, first I need to delete the RC and I need to recreate the RC. If it is RS, I need to delete the RS so that all the pods will be deleted. Then I need to recreate the RS. So when I delete the RC or RS, pods will be deleted and application will have downtime. Application will be down. So here, my code is already running. My application is already running. Customers are accessing my application and I want to deploy the latest code without downtime. 24/7, my application should be up and running. 24/7, my application should be up and running. We can deploy latest code with zero downtime using deployment concept. Right. So here, the advantage of going for the deployment is, one is zero downtime deployments we can do, and the second one is auto scaling we can achieve. In the RC and in the RS, the scaling, increasing the pod counts, decreasing the pod count is a manual process, whereas in the deployment, we can achieve auto scaling. So the main benefits, we can roll back our deployment and we can do zero time deployment and we can achieve auto scaling for our pods. So in the real time, people will use RC or RS or deployment. In the real time, people will use RC or RS or deployment. Which one? Deployment. Why people will go for deployment? Why people will go for deployment concept? What are the benefits? Can I deploy the latest code without stopping my application? Here the advantage is zero downtime deployment. Advantage zero downtime deployment, rollout and rollback deployments. Third one is auto scaling. So in the RC and RS, we are increasing the pods manually and we are decreasing the pods manually. But if you go for deployment concept, automatically we can increase the pods and we can decrease the pods. Are you clear? What is deployment in the Kubernetes? Deployment is one of the Kubernetes component. Deployment is the most recommended approach to deploy our applications in the Kubernetes cluster. Using deployment, we can scale up and we can scale down our pods. Deployment supports rollout and rollback. So if you go for RC and RS, you need to stop your application to deploy latest code, then application will have a downtime. So if you want to deploy your application with zero downtime means my project should not stop. So with zero downtime, we can deploy our applications. So what are the benefits with the deployment? Zero downtime deployment we can do. Rollout and rollback of our deployments we can do. Deployment auto scaling. So automatically pods count will be increased based on the traffic and will be decreased based on the traffic. If more traffic is coming, the pods count will increase. If less traffic is coming, pods count will be decreased. So instead of a manual scaling, we can go for auto scaling. Okay, guys. So in the real time, people will be using deployment. But as per the syllabus, I need to give you some overview on what is RC and what is RS. So if you have the knowledge on RC and RS, then you will understand the power of the deployment. That's why I have explained RC first, then RS, then I'm going for deployment. Clear? So in the real time, for the production deployment, we are going to use this deployment concept. If you want to deploy your application in the Kubernetes cluster, then we need to go for deployment concept. Deployment strategies. So how the pods will be deployed? What are the deployment strategies are available? Deployment strategies. So here guys, in the Kubernetes deployment, we have two strategies. Deployment strategies, we have two strategies. We have two strategies. So the first one is recreate. And the second one is rolling update. So what are the strategies are available here? There are two strategies are available to deploy our application in the Kubernetes cluster. So what are those two strategies? We have below deployment strategies. Okay, when we want to deploy our application in the Kubernetes cluster, and there are two strategies are available. What are those two strategies? One is recreate strategy, another one is rolling update strategy. Okay, now here assume that my application having 3 pods in the cluster. So in which worker node, that doesn't matter. Assume that there are 3 pods are available: pod 1, pod 2 and pod 3. So this is pod 1 and this is pod 2 and this is pod 3. There are 3 pods are available. There are 3 pods are available. Okay. Suppose if I go for a deployment strategy called recreate. If I go for the deployment strategy called recreate, it will delete all the pods at a time and it is going to recreate the new pods. all the pods will be deleted at a time and new pods will be created. So if you go for recreate, application will have a downtime. Why downtime? When it is a recreate, what will happen? All the pods will be deleted in single shot and new pods will be created. Because I want to go for latest deployment, I will go for deployment strategy recreate. When I go for recreate, all the pods will be deleted in the single shot and new pods will be created. So it will take some fraction of seconds to delete all the pods and create the new pods. There we have a downtime of our application. There we will have a downtime of our application. In the rolling update strategy, what will happen is when I want to deploy my code by using rolling update. If I go for rolling update, what it will do is first it will delete one pod, not all the pods. One pod will be deleted. For that one new pod will be created. Then second pod will be deleted. Then new pod will be created. That means one by one it is going to delete and it is going to create. That is the difference between recreate and rolling update. Recreate and rolling update. So now, when you go for recreate, all the pods will be deleted and new pods will be created. Downtime will be available. When you go for rolling update, pod by pod will be deleted and a new pod will be created. So in the rolling update, first pod 1 deleted. In the other 2 pods, our application will be running. For pod 1, new pod will be created. Then pod 2 will be deleted. Then for that, new pod will be created. After that, pod 3 will be deleted and a new pod will be created. So these are called deployment strategies. These are called as deployment strategies in the deployments, right? So the project deployment, if you want to do in the Kubernetes, deployment is the most recommended approach because it is supporting for zero downtime deployment. It is providing rollout and rollback for the deployments, and it is providing auto scaling also. We have below deployment strategies, recreate, rolling update. So what is the meaning of recreate? Recreate means it will delete all pods, all the existing pods. It will delete all the existing pods and it will create new pods. It will create new pods. Downtime will be there. Why downtime? All the pods should be deleted and they should be recreated. Recreate means it will delete all the existing pods and it will create new pods. So here we will go for downtime. Okay, next one, rolling update. What is the meaning of rolling update? Rolling update strategy means it will delete the pod, and creates new pod, create a new pod one by one. In the recreate, all the pods will be deleted at one shot. In the rolling update, pods will be deleted and pods will be recreated one by one. Got my point here? Here guys, when we are writing the deployment manifest YML, if we don't specify the deployment strategy, by default it will take rolling update. If we don't specify deployment strategy, then by default it will consider as rolling update. If you don't specify any strategy in your manifest YML, then by default it will consider as rolling update. So we have below deployment strategies. One is recreate and the second one is rolling update. Recreate means it will delete all the existing pods and it will create new pods. Downtime will be there. Rolling update strategy means it will delete the pods and creates a new pod one by one. So if you don't specify deployment strategy, then by default it will consider as rolling update. By default it will consider as a rolling update. Are you clear? Are you guys clear? What is the deployment? What are the advantages with the deployment? And what are the deployment strategies are available? Good. Now, let me write one manifest YML for deployment. Okay. Deployment.yml. I want to write one manifest file. You know that manifest file contains two things here. One is the service section and another one is manifest. Okay. So here again, concept is same. API version, kind will be available, metadata will be available, spec will be available. API version, for the deployment, the API version will be apps/v1. Kind is a deployment. So what is the purpose of this manifest YML that we will specify in the kind? API version apps/v1. Kind we are giving as deployment. Metadata, in the metadata, we can give the name as Java web app deployment, like this, metadata. Then go to spec. Here we can give replicas. How many replicas you want? I want 2 replicas. I want to create 2 pods. Okay. And strategy. What is your strategy? What is your deployment strategy? There are 2 types of strategies are available. One is recreate, another one is rolling update. You can give any strategy here. You can give the recreate strategy or you can create rolling update strategy also. Then after this strategy, then selector. So selector is match labels. What is the pod label? My pod label is Java web app is the label that I'm going to give. Is the label that I'm going to give. So API version apps/v1. Kind I'm giving as a deployment. Metadata, what is the name of your deployment? We are giving. If you want to delete your application from the cluster, you need to delete that by using this name only. So this is the name of my deployment. Under the specification, I'm giving the replica count as 2. And the strategy I'm giving as recreate. And the labels I'm giving as app:/Java web app. That is a selector. Then we will go for template. Under the specification, the template, pod template. Okay, guys. In the pod template, metadata. In the metadata, I'm giving the name of the pod. So I want to give the name as Java web app pod. And here, I want to give the labels for the pod. Okay. So what is the label we are using in the selector? Java web app is the label we are using in the selector. Then we need to go for container specification. Okay. In the specification, we need to specify containers. What is the name for the container? Java web app container. Now, ports I need to specify and image I need to specify. Ashok ID/Java web app ports. In the ports, I am going to specify my container port. Container will run on the port number 8080. So this is my deployment manifest. In order to deploy your application on the Kubernetes cluster, then we will go for deployment manifest like this. API version apps/v1. Kind is a deployment. Metadata, name I am giving for the deployment. Under the deployment specification, replica count I am giving 2, strategy I am giving as recreate, and selectors I am writing. And in that I am writing a template. This is my pod template. What is the name of the pod? What is the label of the pod? And pod specification. What container, name of the container, and the name of the image and port number. Okay. So with this label, it will identify the pod and it will apply 2 replicas for the pod. It will identify the pod and it will apply 2 replicas for the pod. And pod the strategy I am giving as recreate. If I don't give this strategy, giving the strategy is optional. If I don't give the strategy, what is the default strategy it will take? If I don't give the strategy, what is the default strategy it is going to take? Come on, guys. What is the default strategy? Rolling update. What is the difference between recreate and rolling update? What is the difference between recreate and rolling update? Come on. What is the difference between recreate and rolling update? Recreate means all the pods will be deleted in one shot and new pods will be created. Recreate means all the pods will be deleted in one shot and new pods will be created. When all the pods are deleted in one shot and new pods are created, downtime will be available. How can we avoid the downtime? By using rolling update. When you go for rolling update, all the pods will not be deleted in one shot. It will delete pod by pod. Good. Now, so here we are having deployment specification. Then go for service specification. We have written the service specification several times. Service is used to expose the pods outside the cluster. API version, kind, metadata, and spec. API version, which is v1. Kind, I want to create a service. Metadata, I want to give the name Java Web App Service. Okay. Under the specification, I will specify type. What is the type? The type is node port. The type is node port. And what is the selector? The selector is our label. That is Java Web App. And we need to specify ports. So what is the port? The port is 80. And what is the target port? That is 88. And what is the node port? That is 30785. Like this, we are going to write our service manifest. In the service manifest, version is v1, kind is the service. This is the metadata of the service. Under the specification, what type of service? So now my pods will be created by deployment. How to expose the pods? To expose the pods, we will go for node port, service type. So what is the selector to identify the pods? Pod label. What are the ports? Container running on the 8080, node port 30785. Save it. So this is my deployment. I'm specifying the replica count and I'm specifying the selector and I'm specifying here strategy. Here I can specify strategy. So what is the strategy? You can specify the strategy type as recreate, or you can specify that as a rolling update. You can specify the strategy as a recreate, or you can specify the strategy as a rolling update. Recreate means all the pods will be deleted in one shot and the new pods will be created. Rolling update means one by one it is going to delete the pod and it is going to create the new pod. All right. Now take this YML. Let me delete everything available in my cluster. If you see kubectl get all, it will give you 3 pods are running and 1 service is running and 1 replica set is running. I deployed my application by using replica set. So here it is showing 1 replica set is running and 1 service is running as a node port and 3 pods are running in that. Now I want to delete everything. To delete everything, kubectl delete all all. Now all the pods will be deleted, service will be deleted, replica set is also deleted. Pods deleted, my service is deleted, my replica set is also deleted. Now I want to create deployment. Okay, vi java app deployment.yml. In this YML, let us keep our manifest YML. Yes, it contains deployment specification and it contains service specification. In the deployment specification, I am giving the replica count as 2 and deployment strategy I am giving as recreate. Save this. Now, before doing this command execution, I will show you what are the pods available. kubectl get pods. Any pods available? No. kubectl get service. Any service available related to our application? No. kubectl get a deployment. Any deployments available? No. Pods are not available. Service is not available. Deployment is also not available. Now can I create the application deployment in the Kubernetes cluster? Yes, by using kubectl, I will execute my YML. That means I'm sending a request to control plane. Control plane will receive my request, API server will receive, and it will perform the operation. Good. Let's do this. Kubectl apply -f Java app deployment.yml. Now observe, if you see here, deployment is created and the service is also created. So deployment means my pods are created with recreate strategy. Go to pods, get pods. You can see 2 pods are running. Java web application deployment, 2 pods are running. And go to service and check that our service is running as a node port. The node port number is available. Let us get the deployment, kubectl get deployment. Now our application deployment is running in the cluster. I asked the deployment to create the 2 replicas of the pod. Those 2 replicas are created. Those 2 are available. Those 2 are available. Now you can access our application from its public IP. Okay, guys, take its public IP and go here. What is the port number? 30785 Java web app. So I've deployed my application by using deployment. I deployed my application by using deployment. Got it? So what is the advantage of going for this deployment? What is the advantage of going for this deployment concept, guys? Instead of RC and RS? Instead of RC and RS, what is the advantage of going for this? Zero downtime, auto scaling, rollout and rollback concepts are available. Zero downtime, rollout and rollback concepts are available. Okay. Now, here also the commands we are going to use same. This is my deployment manifest YML. So here also we can use the commands like this. You can delete everything which is available in the cluster by using delete all, apply, Java, app, deploy, deployment.yml. Get pods, get service. Here you need to get the deployment. Here you need to get the deployment. Here you can do the scaling manually by using deployment. Auto scaling is also available. If you want to go for manual scaling, that is also possible. That is also possible. By using this command, we can do the scaling. If you give 5, then pods count will increase. If you give 3, pods count will be decreased. So you can delete everything available in the cluster. You can apply your deployment by using deployment YML. I have given the deployment YML here. Kind is a deployment. Containers will be created. 2 pods, I want 2 replicas. Strategy recreate. You can go for rolling update also. kubectl delete all all. Delete everything available in the cluster and create the deployment by using deployment YML. Get the pods and see in which node the pods are running, and see the service which we have created to expose the pods as node port, and see the deployment that we have. Get deployment. kubectl scale the deployment by using this deployment name and replica count. If I want to delete my application now, guys, if I want to delete my application from the cluster, I should delete the pods or I should delete my deployment. If I want to delete my application, I need to delete the pods or I need to delete the deployment. If I delete the pod, what will happen? If I delete the pod, then what will happen? If I delete the pod, then pod will be recreated because I have given replica as 2. You can see here, I will go here and see kubectl get pods. Now I want to get it -o wide. kubectl get pods -o void. What is happening? Pods are running. 2 pods are running. I want to delete one pod. See, kubectl delete pod name. This is my pod name. Now deploy, delete. After deleting, check the pods. Again, 2 pods are running. So in the deployment also, pods are recreating or pods are not recreating. In the deployments also, pods are recreated. So if I want to delete my application, I should delete the pod or I should delete my deployment. If I want to delete my application, I should delete the pod or I should delete my application. I should delete my deployment. How to delete a deployment? First, let us get everything available in the cluster. kubectl get all. What is the meaning of kubectl get all? Here there are 2 pods running, and here our web application service is running and our deployment is running. Deployment internally using replica set only. Guys, see here. When I'm using the deployment to run my application, internally deployment is using replica set for the deployment. So replica set is using by the deployment or replica set is not using by the deployment? Replica set is used or replica set is not used? Come on. Replica set is used or replica set is not used? Replica set is used. Replica set is used. Good. Now, I want to delete my deployment. How to delete my deployment? First of all, get the deployment. kubectl get deployment. What are the deployments I have created? Java web app deployment I have created. Delete the deployment. kubectl delete deployment name. Then your deployment will be deleted. If the deployment is deleted, our pods will be deleted. If the deployment is deleted, then our pods are deleted. Like this, you can delete your deployment. Okay, you can delete your deployment like this. If you delete the deployment, then your pods will be deleted. Yeah. How to add the auto scaling, that we'll discuss in the upcoming classes. Currently, here I'm doing a manual scaling. How to do the auto scaling of our application, that we will discuss in the upcoming classes. As of now, I just explained what is deployment, how to write the deployment YML, what are the deployment strategies are available, how to create the deployment in the Kubernetes to deploy our application in the pods, right? How to do the auto scaling, that is upcoming topic. Good. All of you clear with my point? Yeah. So with this, what we understood, how to work with replication controller, how to work with replication set, how to work with the deployment, what are the deployment strategies, how to delete the pod, how to scale the pods, scale up the pods, scale down the pods, all that stuff we have understood. In the tomorrow session, we will discuss blue-green deployment strategy. That is the most recommended strategy for deploying our code into production with zero downtime. So in the tomorrow's class, we will talk about blue-green deployment approach. In the real time, how DevOps people will release the project to the production with zero downtime, that we will understand in the tomorrow's class. Okay, tomorrow's class is damn important, guys. In every interview, they will ask a question, how your application will be deployed to production environment. So to deploy our application to the production environment, we will go for blue-green deployment strategy. In the tomorrow session, I will explain blue-green deployment strategy. Got it. Let me upload the notes. Some people told that yesterday class notes is not uploaded. Yesterday class notes is uploaded, guys. People told that class notes not uploaded. It is already uploaded. Yeah. I'm uploading today's class notes. Guys, could you please check it and confirm? Are you able to access the notes? Yeah, good. Yeah, fine, guys. So anybody having any questions, you can ask me now. Guys, yesterday class recording video, yesterday is Sunday, admin is on the leave. Today they will upload yesterday's video and today's video. Okay, yesterday it is holiday for them, so they did not work on yesterday. Today they will upload yesterday's video and today's video. Yeah, fine, guys. Any questions, anyone?
Yes, Ashok. Ashok, so just now you have created multiple manifest YML files today, right?
Right.
So in that you have specified about pod details and service details, but
Correct.
now namespace. Is it not recommended or
Names
not required?
not recommended. I did not give the namespace. So in the yesterday session, we discussed how to create
Yes.
how to add it, right?
Mm-hmm.
We can add that namespace here also.
Okay. I mean, my question is like, is it mandatory in live?
In the real time, definitely we will use namespaces. Yes.
Okay. Yeah. And one more question is related to recreation of these pods. So when you are upscaling it, so right now you have upscaled it to number 5, right? Where we have created 3 at the as per the YML file, and we have upscaled it 5. So after upscaling, it will get automatically downscaled, or like do we need?
No, you need to do the downscaling. Whenever you increase the pod count to 5, always 5 pods will run. If you don't want 5, then you need to downscale them. So if you don't downscale, 5 pods will be running for your application.
Okay, and that will also be distributed as per its own, right? Like as per the AWS application, we are not going to push it into some node or to the other, correct?
No.
Okay, thanks.
Ashok, what is the significance of API version? Initially, I guess you have given V1 only, and now today, as I can see, apps/V1.
Yes, sir. So based on the Kubernetes resources, the versions will be different. I will give the list of versions for which resource, which version we have to use. Okay. For the deployment and for the replica set, the version is apps/V1.
Okay.
For the normal pod, for the service, it is V1, just V1.
So what is the use of API version? Like other thing, like, we have given metadata. So in the metadata, we have mentioned
API version will represent what are the keys that we can use in that manifest YML. Okay, here we are writing metadata, label, strategy. So those are the predefined keys. So which keys should be part of which version, that will be represented.
Okay, thank you.
Ashok, one question. Suppose for the rolling fashion you are talking about, in that situation, suppose that if I have the 2 different versions, V1 and V2 Java application, and I want to deploy in that.
Tomorrow topic is that only, sir. Blue-green deployment.
Okay, got it. Yep.
Hello, sir.
Yeah, hi.
I have one question. For example, if we specify replica set as 3 in manifest file,
Yeah.
and here we scale down it to the 2, then what will be the scenario?
You have created replication
as 3.
Yeah, you created you given the replicas as 3. 3
Yeah.
pods are created. You
Yeah.
scale down to 2. Then only 2 pods will be available.
Okay.
Yep.
Thank you.
Yeah, hi Ashok. Actually, we have received the T2 micro amount bill like 10 or 20 rupees. So we can pay it now, or we can wait. We can make it 0 after EKS
you wait.
usage.
You wait. This month end will make it as 0.
Okay, after EKS usage, right?
Yes, after EKS completed, then we can make it as 0.
The whole amount.
Correct.
Okay, thank you.
Ashok, one more question. So right now we are working on a particular cluster, right?
Correct.
So if we want to create another cluster, like new cluster, I want to create it with the same name by deleting the present one. Can we do it?
Yeah, you can do it. You can do it. EKCTL delete double-hyphen name, cluster name, double-hyphen region. If with that command, the cluster will be deleted. If you want to create, complete cluster will be deleted. If you want to recreate, same EKCTL command, just give you a different name for the cluster. Another cluster will be created.
So the same name will not be taken by EKS?
Every cluster should have a different name in the same region.
Even after it is deleted?
If after deletion, you can create it.
After deletion itself, we can create the same name.
Now don't create the 2 clusters because a lot of bill will be generated if you run 2 clusters.
No. Actually, I was trying to delete the present one and recreate the new one. So
if you delete it with the same name, you can create it again.
Okay, that's what my question. Thanks.
Hello, sir.
Hello, sir.
Yeah, hi.
So, sir, when will the strategies will come into use in real time? We are writing the YML file, recreate and rolling update.
Yeah, tomorrow in the blue-green deployment, I will tell you that.
Okay, sir. Thank you.
Hello, sir.
Yeah, hi.
Sir, for different applications, we need to write a different deployment and manifest service file.
Yes, sir. Every project will have its own manifest YMLs.
Okay, sir. Thank you, sir.
And those manifest YMLs will keep in the Git repository itself.
Okay, sir. Okay, sir. So suppose if we want, like we have a normal applications, for that applications we can deploy. So we have a normal application that is developed and put into the GitHub repository. So for that particular project, we can create our own like YAML, like different Kubernetes files, and we can deploy our applications to the cluster. Sir.
Right. The first thing is, once your code is ready, first you need to write the Docker file. You need to create the Docker image, and you need to push into Docker Hub. Then you will write the Kubernetes deployment YML, and you will create the deployment in the Kubernetes. So to do the Kubernetes deployment, a Docker image is mandatory.
Sir, Docker images that we created will be pushed into the whether into the AWS ECR or what?
Anything.
For
Docker project to project, it will be different. Some people will go for AWS ECR. Some people will go for Nexus. Some people will go for Docker Hub. It depends on.
Okay, sir. Thank you, sir.
Fine, guys. Good. Thank you. With this, I'm stopping for today. We'll meet again in the tomorrow's class. Please practice replication controller, replication set, and deployment. These are damn important for the Kubernetes. So tomorrow topic is blue-green deployment. For that, you need to complete your deployment practice. How to write the deployment manifest, how to create the deployment, how to scale up, how to scale down, how to delete the deployment. All this is required to understand the tomorrow's topic. Don't miss the tomorrow's class. It is very, 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 very important for the interview as well as in the real time. To deploy the productions, to deploy the project into production with 0 downtime, in the real time, people will follow blue-green deployment. Tomorrow, I will explain that. Thank you, guys.